Now, what's a way we could maybe check some of our work here to see that it's accurate? Okay, and that's a good question. All these questions are about the graph of some function, right? That function x plus 1 over x plus 2. So if we could actually see that function, that would maybe help us answer some of those questions, whether or not we got this correct. And so we have the technology. We can do that, okay? And so what I'm going to show you is how you can use your graphing calculator to check some of these answers and see if they look reasonable. And so we want to graph x plus 1 over x plus 2 first. And so the way we do that, if you've never graphed a function on your calculator before, there's a button right here that says y equals. And what this allows you to do is input an equation or a function to be graphed. And so we want to graph x plus 1 over x plus 2. So we're going to hit y equals. And the way that you put this in is really important. When you start working with fractions on these calculators, you always want to group the numerators and denominators together. So I'm going to put in an x plus 1 in parentheses for the numerator. So there's my open parentheses. To get an x, you can hit this button right here. We'll give you an x on this menu. And then we want x plus 1. Close our parentheses. And for a fraction, we're going to use division. So divided by, and then in the denominator, the same thing. X plus 2. And then close parentheses. And so, so that's how we're going to put it in. Now to graph this, you can just hit, there's a button right here that says graph, kind of the top right corner, and you're going to get a picture, and it may look something like that. Now your screen may not look like my screen, depending on if you graphed anything before, if some of your settings have been changed, that might look different. One thing that's going to make that look different is what's called the window settings. The window settings, you see the button that says window right here. These basically set up what part of the graph you see. It's sort of like your viewing window for the graph. And you see there's several settings, X min, X max. If you look on down, there's a Y min and a Y max. And then there's also a scale, X scale and Y scale for X and Y. And then also there's what's called X resolution. And so what these do, the X min, the X max, those are the minimum and maximum X values you will see on the graph. So this current picture I've got here is just showing the left side of the graph is -10, the right side is +10. So if I want to see more of the x-axis, I could change that to maybe -10 and then 20. You can just arrow down and type over and do a 20. Now what that's going to do is that's going to show more of the right side of the graph. So if I hit graph now, it's going to redraw, and you'll notice I can see a whole lot more on the right side because now this is going all the way up to 20. Okay, and then I can take this and change it back to 10, and it's going to look like it did just a second ago because now this right value stops at 10. If you change the X minimum, it's going to change how much of the negative values you can see. The Y minimum maximum does the same thing. Change that Y max or Y min value. Let's change Y min to say -5. So now I'm going to see less on the lower side of the Y axis. See, now I'm just seeing from -5 to 10. And so you can use those to set up your viewing window. If your window ever gets just messed up and you need to fix it, you can set it back to standard settings. There's this zoom button has several different operations you can use, and we'll look at some of those here in a second. But if you'll hit the up arrow, it's going to jump you all the way around to the bottom. And actually, there were more things here than I was looking for. What I'm looking for is number 6 there. So actually, when you just hit the zoom, really I was just looking for number 6, which is Z standard. And what that is sets it back to the standard viewing window. So it resets it from -10 to 10 on the X and Y min and max. Now these other values in your window, this X scale, what that does is it sets the tick marks for your X-axis. So if I change that to 2, what I want you to notice is, notice I have less tick marks on my X-axis. Now that's basically got a tick mark at 0, 2, 4, 6, 8, 10, and so on, going up by 2s. If I change that to 5, now I just have tick marks at 0, 5, 10, -5, and -10. So that just basically changes your tick marks. The resolution, you really don't need to worry about that. That's a setting that you shouldn't ever have to really deal with. And so here's our graph. Now let's go back and look at some of those questions we asked. Is the point 1 1/2 on the graph of f? Okay, looking at our graph, again the question is the point 1 1/2 on the graph? Now 1 1/2, that x value 1, y value 1/2 is going to be right in this area right here. That's kind of tough to see. Is 1 1/2 on the graph of this function? Because it kind of, is that 1/2? The resolution on the screen is not that great. What we can do is we can zoom in if we want to get a better picture. And so what I did was I hit zoom. Let me go back there. And then I arrowed down to zoom in and hit enter. So I want to zoom in. Now you should see a little blinking pixel right in the middle of the screen. The calculator is wondering where we want to zoom in on that graph. And really I'm interested in that area around 1 1/2. So you'll notice I can use these arrow keys to move that blinking pixel around. So I'm going to move it around that 1 1/2 area. And once you've got it where you want to zoom in, just hit enter. It's going to zoom in and redraw your graph. Okay, and so now I'm zoomed in. Here's my X and my Y axis. You can see I can see a lot more around that area I was interested in. I really can't tell if that is 1 1/2 though. So there's another function that's really useful. It's called trace. If I hit this trace button, which is next to graph, what that does is that allows me to trace along that graph. And so notice there's a big blinking X on the graph now. So I can use my arrow keys going right and left and trace along that graph. And as it moves, it gives me the X and the Y value for that point on the graph. So I could actually trace over to around the X value of 1, which that's about as close as I can get. And you can see my Y value is 0.667. Isn't that awfully close to the 2/3 that we came up with for our answer over here? 2/3 is 0.6 repeating. And so we can see that if you're at an X value 1, your Y value is not 1/2. We can actually take it straight to the X value 1 also. While you're in that trace mode, if you type in a number like a 1, notice in the bottom corner it pops up X equals. X equals 1. If I hit enter, it will take me straight to that X value 1. And so now I can see, sure enough, that X value 1 does have a Y value of 0.6 repeating, or 2/3. So I verified that answer using the calculator. Jumping down to part B, if X is 2, what's f of X? Well, I'm kind of set up to answer that question pretty quickly, aren't I? If X is 2, what's f of X? Let me do... maybe get that bigger where you guys can see it. If X is 2, what's f of X? Well, if I hit, again, wanting to know what X value of 2 is, well, if I hit 2 and hit enter, I get 0.75. So, hey, if I look at what I got back here, hopefully our answer matches. Sure enough, we got 2 3/4 for the Y value. That's 0.75. Okay, so that's good. Part C, if f of X is 2, what is X? So let's see if we can answer that question. Now we can't really answer that in such an easy way as what we just did, where we can type in the x value, because there's no way to input a y value into this trace thing. So the best we can do, let me reset my window. I'm going to hit zoom and then number 6. I can actually just hit number 6, reset my zoom. If my y value is 2, then what is my x value? If f of x is 2, what's x? Notice the way this graph sets up, and we're going to talk a lot about graphs that are shaped like this in Chapter 5 when we talk about rational functions, but this graph is actually split into two parts. We have a lower piece here, then we have an upper piece here. And there's actually a boundary right here, and this lower piece is totally separate from this upper piece. And so I say that to say that when we get to a y value of 2, here's our y value 2 on the y-axis. That's going to be over here, somewhere around an x value of what? If I hit trace, just verifying my answer, what I can do is I can punch in maybe -3 and see what that gives us. Yeah, see, that gave us that y value of 2 at x equal -3. So that does verify that as well. And then the last question, what are the x-intercepts of the graph of f, if there are any? We got an x-intercept of -1, 0. And again, we can verify that just punching in a -1. Sure enough, there's that y value 0. So you can use your calculator to verify these answers if you know how to operate the graph and kind of work with that. Can find those answers and double check them using that graph. Okay, the last question in the notes here. This is a calculator question. It says the average cost C of manufacturing X computers per day is given by this function. So this whole big thing here. It says determine the average cost of manufacturing 30 computers per day, 40 computers per day, and 50 computers per day. And so really what that's saying, remember, X is the number of computers per day. So 30 computers per day, that's C bar of 30. Now we have a couple of options. We can plug that in by hand and work it through, but that's probably going to be a lot of work. We do have a calculator, so let's see what we can do with that. Now the way I'm going to do this, I'm going to use a table to find these answers. Since I need to plug 3 different values in, I'm going to use a table to do this, so I can show you how to do this. This is a really useful thing to know. The first thing I need to do is type in that function like I'm going to graph it. Okay, so I'm going to hit y equals. If you want to clear out something that you've already typed in, you can punch clear. It'll clear that function out. And so typing in that function's 0.56x squared. Trying to see if I can. That's not going to work. Okay, 0.56x squared minus 34.39x plus 1212.57 Oops, typo. You can, if you type in something wrong, just arrow over and hit your delete button, and that'll erase it. And then plus 20,000 over x. And actually, I should probably put, that's not a bad practice, to put that fraction in parentheses. If you need to add a character in that you skipped, right above delete, it says insert, INS. So hit second delete, it puts you in an insert mode, and I can drop in an open parentheses there. And so I've typed in that whole function. Okay. Now, I don't actually want to graph it. What I want to do is I want to look at a table. Okay, so the way that I can look at a table is, notice above graph, it says table in blue letters. So anytime you see something in blue, you hit second, and then you hit that button, and it's going to take you to a table. And so what this is, it's just a normal little XY table. So I can see X values here, and then their corresponding Y values for this function I've typed in. So it's pretty handy. Now, my first question, I believe, was for 30 computers, so an X value of 30. The way that I get down to 30 is you can use your arrow keys to just scroll down through this. Now, it's going to be a lot of scrolling to get to 30. So what can I actually do? Well, just like on, I thought I could, never mind. So it's going to be a lot of scrolling to get to 30. So what I can actually do is I can set this table up to where it starts at 30. Right above window in blue letters, there's TBL set. That's table setup. So hit second window. And there's two numbers here. There's TBL start. What that is, that's where your table starts. So since my first number is 30, I'm going to start it at 30. The next one is a delta table. That's a Greek letter delta, that little triangle. Really what that controls is how much your X values increase with each row in the table. So delta table 1 means it's going to start at 30, and then the next entry is going to be 31, 32, 33. The X values go up by 1. Now my question over here goes 30, 40, 50. So it would make sense then to put an X value of, or I'm sorry, a delta table of 10. So then my table goes 30, 40, 50. Now if I look at my table, there's the numbers I need. An X value of 30, I get 1351.54. The average cost of computing 30 or manufacturing 30 per day. Next, for 40 computers per day, just go on down here, 1232.97. And then 50 computers per day, 1293.07. Do a little better. I think I copied that wrong. Nope. Okay, good. All right, cool. So there I've answered all those questions without really having to plug anything into this function. I just had to make sure I got it typed in correctly, and then from there you can make a table to get all of that information. And that's it for section 3.2. So if you have questions on the homework as you're working that, definitely get in touch with me. I'll be glad to help you out. If you want to see more examples or anything for any of the problems we worked, shoot me an email, and I'll be glad to work some more out for you.